We are going to work on adding and subtracting rational expressions today. So basically all that means is we're going to add and subtract fractions. Okay, so adding and subtracting fractions. So we are on 7.2. Zoom for you guys just a little bit. Okay, there's actually two different parts for today. So the first one is going to be add and subtract rational expressions. And does anyone remember what is a rational expression? Ratios, so fractions. Okay, so fractions. Rational expressions are basically just fractions with letters in them. Okay, so fractions with letters. So for example 1, if I asked you to combine 7x plus 3y over 6x plus 8y minus 4x minus y over 6x plus 8y. So combine and give me your answer in lowest terms. All your instructions are always going to say give answer in lowest terms. So first thing you have to do when you're dealing with rational expressions is see if they have a common denominator. This one does have a common denominator, so you do not have to change anything about the denominators. All you really have to do here is subtract. But what's the key here? What would you think that you remember to have to do? Distribute this negative. Okay? You're actually subtracting everything here. So what you really need to do is rewrite the first one, 7x plus 3y. Distribute this negative, so that would give you minus 4x. Negative times negative gives you plus 4y. Or sorry, plus y. Then you can write it all over one fraction. So since the denominator is the same, it's just 6x plus 8y. Then combine your like terms. So what's 7x minus 4x? 7x minus 4x gives you 3x. 3y plus 1y is plus 4y over 6x plus 8y. Then we're right back to what we did in 7.1. What do I have to do to see if I can simplify that? Factor and reduce if you can. So in the numerator, nothing reduces. So 3x plus 4y over 2 times 3x plus 4y. Then what do you think we can do? That's good. Okay, then you can, what'd you say? Yeah, like so much ordeal just to order lunch. Okay, then this drops away. What's left in the numerator? A 1. In the top, it's 1 over 2. Okay, this does not reduce to 2. You have to leave a placeholder 1 in the numerator. So this actually reduces to 1/2. Okay, make sure that you don't forget that placeholder 1 when you need one. Okay, next one. Let's try number 2. Let's go x plus 18 over x squared minus 4x minus 12 plus 2 over x plus 2. X plus 18 over x squared minus 4x minus 12 plus 2 over x plus 2. So here we have to find something called an LCM. Okay? LCM is basically the exact same thing as a common denominator. Okay? Say it again. Least common multiple, right? So what is the smallest thing that both of these denominators would go into? Okay, hold on. Not what they both have in common, not their GCF, but their LCM. So first thing you have to do is factor any denominator that's not factored. So how would this factor? How could you factor x squared minus 4x minus 12? X minus 6 and x plus 2. X minus 6 and x plus 2. The LCM is what both of these would go into, okay? So this is, I'm going to cross this out. Basically, if we wanted to find the common denominator, okay, what would you say is the common denominator for both of these fractions? X plus 6 and x minus 2, right? The LCM is the same thing. It's x minus 6 and x plus 2. Okay, so to find the common denominator, basically when you were in elementary school, your teachers actually really did you a disservice, okay? If you were figuring out something like, let me give you something easy. So like 1 over 6 plus 1 over 4, okay? Did a lot of your teachers tell you, whatever the denominator is, just multiply it by the other one? How many of you guys heard that? To get a common denominator, you just multiply by whatever the other one is. Did some of you guys hear that? Okay. That's a problem, because then you ended up with really large fractions, okay, and you had to reduce. Well, it's not a really big deal when you're just using simple numbers, but when you're using binomials and trinomials, it's a problem, okay? We don't want to multiply, just multiply by the other one. You get super big numbers, you have to do a ton of factoring. So it's better if you found something called the LCM, okay? If I showed you just this super simple problem, 6 actually breaks down to be 2 times 3, right? 4 would actually break into 2 times 2. If I wanted to figure out the LCM here, you have to figure out, basically, you don't have to write this part down. Basically, what would cancel out both of them? You'd have to have a 2 and a 3. So we would take care of that 2, that 3. We've already taken care of 1, 2, and you need another one. So actually, the LCM here is, what's 2 times 3 times 2? 12, okay? The LCM is 12. So you could have found a common denominator by just getting it to 12. Now this is a really simple example for this. But with binomials, your LCM is basically just what would cancel out everything. Okay, so what would cancel out everything? And we're going to use this in the second half of our notes today, and you'll see why in just a minute. So for this one has both of them. This one, what is it missing? The x minus 6. So we're going to multiply both the top and the bottom by x minus 6. Now, good news here is you never actually have to multiply these together. Okay, so I do not want you doing any foiling. Do not worry about that part. Okay, what I do want you to do is make this all one big fraction. So we know it's going to be x plus 18. This one, since you have a plus 2, you're going to distribute a positive 2 into both of these. So if you distribute positive 2, we've got plus 2x minus 12 over, I don't actually want you multiplying these together, I just want you to rewrite them. So x minus 6 times x plus 2. Then we combine like terms, so x plus 2x gives you what? 3x, positive 18 minus 12 gives you what? Plus 6. I'm not trying to ask trick questions. Then we want to factor this. This denominator would be the same, so I'm not going to rewrite it because I don't feel like it. Then to figure out if anything can reduce, we have to factor this. How can you factor 3x plus 6? GCF of 3, what's left behind? X plus 2. Rewrite it over your whole denominator. So it'd be x minus 6 and x plus 2. Then reduce if you can. So what reduces here? The x plus 2's. Rewrite this, you've got 3 over x minus 6, and can anything else reduce? Can I reduce the 3 and the 6? No, because this is attached to something else by plus or minus. That's the answer that I'm looking for. Okay, so we're just getting a common denominator, getting both the fractions to be that common denominator, and then reducing things. Okay, let's try a couple more. Okay, if I gave you something like, sorry, let me make sure that this is the one I really want to do. Let's try this one first. Okay, number 3, I'd like you to subtract 6 over x squared plus 2x minus 8 minus 8 over x plus 4. And a lot of times your questions on your test or a quiz are going to ask you which expression is equivalent to. Basically, that just means add or subtract. Okay, so it sounds a lot more complicated, but it's really not. What'd you say, Kev? I thought you said something. Sorry.
I just sneezed and used like these sneeze
Okay. So first thing you want to do is figure out what's the common denominator here. So we want to factor. How can you factor x squared plus 2x minus 8? What does that factor into? What multiplies a negative 8? Right. X plus 4 and x minus 2. So once that's factored, I'm just going to cross this out just so it doesn't confuse us. So what is this second fraction missing? What's the second fraction missing? The x minus 2. So you multiply it. Okay, then I actually want you to multiply it out. So this is just a 6. Now here, what are you actually distributing into those parentheses? What do I distribute into this parentheses? A negative 8. Okay, you have to take that negative with it. So when you distribute a negative 8, we get minus 8x plus 16 over, leave this factored, so x plus 4 and x minus 2. Then combine your like terms, so negative 8x plus 22. Tanner, write this down. Over x plus 4 and x minus 2. Now, do you think anything's going to be able to reduce? How do we know? What do we have to do before we can figure out if something's going to reduce? Factor. So what's the GCF between these two? What's the GCF for negative 8 and positive 22? Negative 2. Take it out, you'd have x minus 11 over still x plus 4 and x minus 2. And can anything reduce? Does anything reduce there? No. So that's your answer. Okay? You do have to factor just in case, but it's not always going to reduce away. Okay? Now, just to be aware, you could also see this answer written multiplied out. So you could see it as negative 2x plus 22. There was a 4 here. Negative 8x. Sorry. You could see this written as negative 8x over, if you FOILed these together, we'd get back what we started with, and it was x squared plus 2x minus 8. You could see those written on a multiple choice question in either form. Okay, to be honest, on some of this test, some of the answers are actually multiplied out, some of them are factored out. So you do need to be able to make sure that you understand that those are equivalent to one another. And it does not matter to me which way you write answers. Okay, it doesn't matter if they're completely factored or if they're multiplied out. Questions on how I did that? Okay, let's try another one. Number 4. I know you guys are complaining about these, but I'm doing basically all the kind that are on your test. So I want to make sure that you understand them. Okay, so x squared minus 5x plus 6 plus 5 over x squared minus 8x plus 12. 2 over x squared minus 5x plus 6 plus 5 over x squared minus 8x plus 12. So, to find the least common denominator, or the LCM, factor both of these denominators. So, what would factor to give you x squared minus 5x plus 6? How does that factor? What are both your signs going to be? Both plus, both minus, or one of each? Both negative. So what multiplies to 6 adds to 5? 2 and 3. If you do 6 and 1, it doesn't work correctly with the signs. Okay, it doesn't work right with the signs, so be careful on that one. This one, what multiplies to negative 8 adds to positive 12. Both negatives, what multiplies to 12 adds to 8? 2 and 6. Okay, so here, what would the LCM be? The LCM is all of the ones that you need. So you need an x minus 2, you need an x minus 3, and what else? And an x minus 6. Okay, so that would be your LCM here. So what's the first one missing? And I'm going to go ahead and cross these out just so it doesn't get confusing. What's the first one missing? The first fraction. An x minus 6. So multiply by both the top and the bottom. What's the second one missing? The x minus 3. Then actually distribute these through. So 2 times x gives you 2x minus 12. Multiply a positive 5, so plus 5x. 5 times negative 3 gives you minus 15 over all of this in the denominator. Does not matter which order you write these in. Okay, so if you write these in a different order than I have, it's the same thing. Okay, because they're all being multiplied together. What do you think is my next step?
Wow.
Combine like terms. I'm sorry, Tyler Kuhn? No, that's my last name.
An actual business skill.
There's the Tyler Kuhn. That's okay. It's okay. Thank you. Not a problem. Thanks. Apparently adopted Tyler. Tyler, you're leaving. Asked for Tyler Kuhn. Like, no, I don't have that child. Okay, so combine like terms. 2x plus 5x gives you 7x. Combine the numbers, so negative 12, negative 15 gives you what? Minus 27. I know it's Friday, but over x minus 2 times x minus 3 times x minus 6. Is there any GCF you can take out of the numerator? Can I factor that and possibly reduce anything? No. So you're done. That does not factor any further. Questions so far? Besides, when are we going to be done? Okay. Keep going. I know you guys don't like these, but
I think this is the last one.
no, it's not. It's the last one of this kind.
Yeah, that's what I mean.
Okay, for number 15. Or number 15, sorry, number 5. If I'd like you to combine 1 over x minus y plus x over y minus x. 1 over x minus y plus x over y minus x. Are these common denominators? Not
I'd
quite.
say no.
No.
Probably have to flip them maybe.
You do have to flip them. Okay, if you flip them, if I wanted to change this to be just like the first one, how could I flip this to be exactly opposite? This is negative x plus y. How do I change these? These are opposites of one another. So how do I change something? Okay, you could multiply by a negative 1, or think of it as taking out a negative 1. If you divide out a negative 1, these would become the same. Okay, so to change this to be divide out a negative 1, all you have to do is put the negative up in the middle. So this would be 1 over x minus y plus negative x over x minus y, and it flips it to be exactly the same. Then, since these are a common denominator, you just write them all on the same fraction. Okay, make it into one fraction. That would give you 1 minus x over x minus y. 1 minus x over x minus y. That's your answer. You're done. Okay, so working with opposites. To get something to be exactly the same, you factor out a negative 1. Okay, multiply by a negative or divide by a negative is basically the same thing. Okay, next part we're going to do is simplify something called complex fractions. Simplify complex fractions, okay? Complex fractions are what I would refer to as something called double-decker fractions. Okay, you guys may have seen these before. I'm not 100% sure. And we're going to ask you to simplify x over 4 minus 1 over x divided by 1 over 2x plus 1 over 4. That's something called a complex fraction, okay? Or I would refer to it as a double-decker fraction. What we want to do to simplify complex fractions is you first want to look at all the denominators. Okay, so all the denominators. So a 4, an x, a 2x, and a 4. And from those denominators, you want to figure out what number would cancel out every single one of these denominators. What could you multiply by to cancel out a 4 and an x and a 2x and a 4? What would cancel out a 4? Not what goes into all of them, but what would cancel out, you know you have to have a 4. We know we're going to have an x. If I multiplied by a 4 and an x, would it cancel out the 2x? Yes. If I multiplied by 4, would it cancel out with this 4? Yes. So you have to figure out what would cancel out all of these denominators. So what is the LCM here? What does 4 and x and 2x and 4 all go into? What do they all go into? 4x. So we want to figure out how to cancel out all of these denominators. So if you wanted to eliminate a 4 and an x and a 2x and a 4, you'd multiply everything by 4x, right? So you're going to write 4x next to every single one of these fractions. Make sure that you write it at the top of each fraction. Okay, if you write it at the bottom, it becomes really confusing. So write this next to every single fraction at the top, next to the numerator. Then I actually want you to reduce. So here, if I multiplied these together, what would reduce? The 4. What would reduce in this fraction? The x. What would reduce in this fraction? The x completely goes away, and 4 and 2 cross-reduce to be what? A 2. What reduces here? The 4. Then you actually multiply through. So x times x gives you what? X squared. Minus 1 times 4 is 4. Over, in the denominator, 2 times 1 is 2. Plus 1 times x is x. Is this fully simplified? No. What can I do in the top? Factor it to be x plus 2 and x minus 2 over 2 plus x. Now, can anything reduce? What reduces? X plus 2 and 2 plus x. Are those opposites of each other? No. Okay? Opposites are only if you have a negative in between. X plus 2 and 2 plus x is the exact same thing. So when you reduce those, it does not become a negative 1. It just cancels away to become a 1, so they cancel each other out. X minus 2 is the answer. And you're done. No. Still have 2 more. Okay, but this problem is done. Okay? I have 2 more for you. Yeah, this is the second one. Yeah, these are the second kind of problems that we're doing. Okay, try another one. If I ask you to simplify x squared plus x over 6 divided by x squared minus 1 over 36. X squared plus x over 6 divided by, Jalen, x squared minus 1 over 36. So if you look at the denominators, what's the denominator of x squared here? 1. Okay, so put these over 1 if it helps you. If you look at just the denominators, a 1, a 6, a 1, and a 36. What would you multiply by to eliminate all of those denominators? 36. So write 36 next to each part. And I would write it at the top. Okay, make sure you write it at the top so that it's easier to cross cancel. Then, does anything cross cancel for this first part of the fraction? Nothing. What cancels here? 6 and 36 reduce to be 6. Nothing reduces here because there's nothing in the denominator. And the second part, 36, reduces away. Then multiply by what's left. So what's left for this first part of the fraction? 36x squared plus what? 6x over 36x squared minus 1. Then factor and try to reduce. So how can you factor this first part, the numerator? Take out a GCF of 6x. What's left behind if you take out a 6x? 6x plus 1 over, how can you factor this denominator? Difference of squares. So 6x plus 1 and 6x minus 1. The 6x plus 1s will reduce each other away. So you're left with 6x over 6x minus 1. Can you reduce these 6x's? No. So you're done. Any questions on how I did that? Okay, and I will let you guys be done after that. Okay? So, homework for this is going to be worksheet 2. You're doing worksheet 2, numbers 1 through 7, as well as part in the book. Okay? I will collect both parts on Monday, for sure. Okay? I am definitely collecting both parts here.